Hello everyone. So let's start with the next topic, that is electric potential due to an electric dipole. First point is electric potential at a point on the axis of dipole. Means we have to determine the electric potential at any point on the axis of dipole, means on axial position. So first of all, let's see the diagram. In the diagram, this is an electric dipole having charges plus q and minus q, and from the center O of the dipole, this center O of the dipole, we have a point P at the distance small r. The distances of each charge from the center of dipole is L as usual. So let's see the derivation. First thing is electric potential at point P due to plus Q, due to charge plus Q. So formula is V1 is equal to 1 upon 4 pi epsilon naught Q upon R minus L. As you can see from the diagram, the distance of this charge plus Q from P will be R minus L. So that's why it is R minus L, and as it is due to plus Q, that's why potential is positive. And due to minus Q, formula V2 is equal to minus times, as it is due to minus Q, minus times 1 upon 4 pi epsilon naught Q upon R plus L. In the diagram you can see the distance of this charge minus Q from point P is R plus L. Similarly, the net potential at point P will be the sum of V1 and V2. So V is equal to V1 plus V2. V is equal to value of V1 1 upon 4 pi epsilon naught Q upon R minus L, minus, actually we are doing the sum but V2 is in negative, that's why minus 1 upon 4 pi epsilon naught Q upon R plus L, taking Q upon 4 pi epsilon naught as common, 1 upon R minus L minus 1 upon R plus L. Again in next line, taking LCM, R plus L minus R plus L upon R square minus L square. V is equal to Q upon 4 pi epsilon naught into R cancel, L plus L 2L upon R square minus L square. As we know, Q into 2L is electric dipole moment P. That's why V is equal to 1 upon 4 pi epsilon naught P upon R square minus L square. Now, we are considering that R is much greater than L, then we can say that R square will be very much greater than L square. So on neglecting L square in comparison with R square, the formula will become V is equal to 1 upon 4 pi epsilon naught P upon R square. So that is the expression of electric potential due to an electric dipole in axial position. Let's move towards the second point, that is electric potential at a point on the equatorial line, or we can say in equatorial position. So let's see the diagram first. This is the electric dipole, minus q plus q, these two charges. This is the center. From the center of dipole at distance small r, we have a point P, and at this point P we have to determine the net potential due to this electric dipole. As this distance is L, this is R, so definitely this will be under root R square plus L square. Similarly, this will also be under root R square plus L square. So let's move towards the derivation. Electric potential at point P due to plus Q, V1 is equal to 1 upon 4 pi epsilon naught Q upon under root R square plus L square. You can see from the diagram, the distance of plus Q from P is under root R square plus L square. Now, electric potential at point P due to minus Q, that is V2, minus times, as it is due to negative charge, minus times 1 upon 4 pi epsilon naught Q upon under root R square plus L square. This distance is also under root R square plus L square. So the net potential at point P, that is V is equal to V1 plus V2. V is equal to V1, value of V1 is 1 upon 4 pi epsilon naught Q upon under root R square plus L square, minus times 1 upon 4 pi epsilon naught Q upon under root R square plus L square. Both the values are same in magnitude, so it will be cancelled. So the net potential in equatorial position due to an an electric dipole is always zero. That is all for this derivation. Thank you.